Welcome to your first online intermediate algebra video. This first unit is kind of a review unit, so there may not be as many examples as you might see in later sections because this is supposed to be review material, but we'll still go through all the objectives together. You'll see some example problems. You'll have the opportunity to practice problems on your own. So let's get started with this section. Okay. All right, our one and only objective for this section is to solve linear equations containing whole numbers, fractions, and decimals. So we'll see at least one example of each of these three kinds. Okay, just kind of a review, a quick reminder of some notes here. This is just a guideline to steps to solve linear equations. This by no means is a hard and fast rule. You can always do things a different way. This is one way I found that's an easy way to go through it. So those steps would be the first one, distribute. That's if possible. It's very possible that each and every step along the way you won't be able to do. So if possible, distribute. Second, combine like terms. This is again, if possible, on each side of the equation. And then third, get the variables on one side, the numbers on the other. This means adding and subtracting things to both sides. And then finally, multiply or divide to undo the final operation on the variable. So if it's multiplication, we'll divide to undo that. If it's division, we'll multiply to undo it. So let's see some problems. Okay, our first problem, a linear equation containing whole numbers. Okay, so step one is distribute. In this case, we do have parentheses, so we can distribute. The 3 gets distributed to the first set of parentheses, giving us 3x plus 12. Remember, the parentheses signifies multiplication. And then the negative 2 can also get distributed. You can choose to view this as a 2 being distributed. If you do that, then you'll have to do a whole separate set where you distribute the negative. So I would suggest in all cases, just distribute the negative with the number as a whole. So negative 2 times x gives us minus 2x, and negative 2 times positive 1 gives us negative 2 or minus 2 equals 15. The second step is combine like terms on each side of the equal sign. On the right side, there's nothing we can do to combine over here. On the left side, we have two variable terms, 3x and negative 2x. You can combine those together, just add or subtract the coefficients. So this is a positive 3, this is a negative 2. They'll combine to be a positive 1x or just x. You don't need to write the 1 there. We also have like terms in the numbers, positive 12, negative 2. If you combine these two together, it's sort of like having $12 and owing $2. You'll get a positive 12. If you have $12 and you owe $2, they'll combine together and you will still have $10 equals 15. Then we're in the third step. Add or subtract things to both sides to get the variable term on one side and the numbers on the other. So we only have one variable term. It's already isolated. So we'll undo this operation of addition. Opposite of addition is subtraction. Subtract 10 from both sides. Remember, this doesn't need to be written with a coefficient of 1. We can just write x is equal to 15 minus 10, 5. And that's our final answer. Step 4 is multiply or divide to undo the operation on x, on the variable. In this case, there is not an operation remaining. If you chose to leave the coefficient of 1 and then divided both sides by 1, you'd still get the same final answer of 5. A lot of textbooks will suggest that you take this number, this solution, and plug it back into the initial problem to check that it is a true solution. And you can do that if you want to, but it's not necessary. Remember that our goal in solving these linear equations is to figure out what value can be plugged in to make this a true statement. So I'm going to plug this one in and verify for this problem, but like I said, it's not something we'll do as a default. It's not something I expect you to do as a default. It's just if you want to. So this is our check. Okay, so if we plug in 5 instead of x into the equation, minus 2 times 5 plus 1 equals 15. We can verify by using order of operations on each side of the equal sign. So on the left, we'll go through GEMDAS or PEMDAS, whichever way you think of it. Parentheses or grouping symbols first. So inside this first parentheses, we get 9. Inside the second parentheses, we get 6. Next thing we would look for would be exponents. We don't have any exponents here, so we can skip down to multiply or divide in PEMDAS or GEMDAS. We only have multiplication, so we'll carry out each of those multiplications. 3 times 9, 27, minus 2 times 6 is 12. If there were multiple operations on the right-hand side, we could do those at the same time. You can do them separately. It's up to you. There's just a number over there, so we're going to leave it there. And finally, 27 minus 12 gives us 15. So we got a true statement, 15 equals 15, which means this solution has been checked. Again, you do not need to check if you don't want to. It's a way you can verify for yourself. But it's up to you. Okay, so this is a whole number problem. Let's see another one. And erase. Okay, so here's a fraction problem. X over 2 plus x over 3 equals 3/4. So with a fraction problem, the first thing you'll need, and there's a lot of ways you can do this. You can still follow those same 4 steps to go through these problems, to go through fraction problems, but it's sometimes easier to deal with them if you get rid of the fraction. Fractions are not my favorite. For a lot of people, it's not their favorite either. So if we choose to get rid of the fraction first, this is the process we'll follow. And then I'll go back and do this problem a second way where we just follow those steps. Okay, so first of all, if we're getting rid of fractions, this is option 1. We need a least common denominator, and our denominators are 2, 3, and 4. So our least common denominator would be 12. It's the smallest number that we can multiply any of these denominators by a certain number to get 12. You could use 24, you could use 48, 36. This is the smallest one. And truthfully, if you don't use 12, if you use something else, that would be fine. 12 is just the smallest one. So to make these conversions, we're going to multiply each individual fraction by a form of 1 to get them to have 12 as a denominator. This is what we want, each and every denominator to be 12. Okay, so the first fraction has a denominator of 2. If we want to change that to have a denominator of 12, we need to multiply it by 6. But we can't just choose to multiply one single item by 6. We have to multiply by a form of 1. So we're going to multiply by 6 over 6. I choose 6 over 6 because that's equal to 1. And we can multiply anything by 1 and it doesn't change it. It just makes us look at it a different way. Instead of looking at it as the current fraction we have, which is 1/2, when we multiply it by 6 over 6, currently we have 1/2. When we multiply it by 6 over 6, we get 6x over 12. This means instead we have 1, 2, 3, 4, 5, 6 on each side. We have 12ths, and we have 6 of them. 6 12ths. Shade in, 1, 2, 3, 4, 5, 6. So we have the same information represented in different ways. We're not changing anything here. Okay, our second fraction has a denominator of 3. In order to get it to have a denominator of 12, we'll multiply the top and bottom by 4. Again, 4 over 4 is equal to 1. So this will give us 4x in the numerator here. And then our last fraction has a denominator of 4. We'll multiply the top and bottom by 3. 3 times 3 gives us 9 over 12. And now we can use a nice trick here. Now that everything has the same denominator, we make the decision to multiply both sides of the equation by 12. We can choose to do whatever we want to both sides of an equation, as long as we do it to both sides. The equal sign is the balance of the scale. So if I'm starting out with the same information on both sides, if I multiply everything by 12, both sides are heavier, but they're still equal. So this is different than what happened in the previous step. We multiplied by seemingly different things, but they all simplified down to 1. Here we are multiplying both sides by a number other than 1. We're choosing 12. And we choose 12 because 12 would get distributed on the left and just multiplied on the right. And if we multiply something, you can sort of look at this as the 12 is multiplying up here. If we multiply something by a fraction with the same denominator, those numbers cancel out or essentially break down to 1. So then we're multiplying by a form of 1. So this 12 and this 12 will cancel, this 12 and this 12 will cancel, and we're left with just these numerators. 6x plus 4x equals 9. And then we continue solving in a similar manner to the previous problem. So we can combine like terms and get 10x equals 9. We have the variable term on one side, step 3 is complete, and the constant on the other. So our last step, undo the operation on the variable. It's currently being multiplied. So we divide each side by 10, giving us 9/10. So this is one way to solve this problem, 9/10. This is option 1. This is a way where we are getting rid of the fraction. Okay. Let's see this problem a different way. Let's say we choose to solve this problem using those 4 steps. We'll strategically follow them. So the first one is distribute. There's no parentheses here, so nothing to distribute. The second is combine like terms on each side of the equal sign. On the right, we only have one term, so there's nothing to combine over here. On the left, we have 2 variable terms, so we'll combine them together. But in order to add them together, we need a least common denominator. So if we're focusing just on these 2 terms, our least common denominator comes from the denominators of 2 and 3. We can multiply each of them by something to get 6, and that's the smallest number that will come out of it. So we will change the first fraction, we'll modify the first fraction. In order to get that denominator of 6, we need to multiply by 3 over 3, another form of 1, giving us 3x over 6. The second fraction gets multiplied by 2 over 2, which gives us 2x over 6. And remember, we found a least common denominator and converted so that we could add these 2 things together, combine the like terms. When you combine like terms, their denominator remains the same, and you just add or subtract the numerators. 3x plus 2x is 5x. This is option 2. Okay, so now we have 5x over 6 equals 3/4. And there's a lot of ways you could proceed from here. I'm going to go through it one way. There's lots of other ways that are possible. Maybe we'll do a second way. One way, that third step is adding and subtracting to get the variable term on one side, number on the other. We have that. The last step is to undo the operation on the variable, so multiplication or division. So currently, we see that 5/6 is multiplying x. So we can undo that by dividing both sides by the fraction 5/6. And if we choose to do this, a same numerator top and bottom simplifies to 1, leaving us with x. And on the other side, we have 3/4 divided by 5/6, which can be looked at and changed to multiplication using keep, change, flip, which says, let's bring this up here. Keep the first fraction the same, change to multiplication, flip the second one upside down. And then simplify from here. Multiply straight across, cross cancel, whatever you want to do. Multiplying gives us 18/20, which simplifies to 9/10, which is what we got doing it the other way. Let's do another way from here. So let's go back to this line where we have 5x/6 equals 3/4. It's just another way of solving from this point in the problem. Some of you may have been inclined to do it this way, and this is perfectly fine, is to multiply by the reciprocal. If we multiply by this reciprocal, on the left-hand side, 5 and 5 cancel, 6 and 6 cancel, leaving you with just x. And on the right, we basically get the second to last line that we had doing it the other way. 3/4 times 6/5, which gives us 18/20, which is again 9/10. The same answer we got doing this problem a few different ways. I don't have a preference with fractions. Whatever way you're comfortable working the problem out is perfectly fine, as long as you're getting to this 9/10 solution. Okay, let's do one more fraction problem. A lot of people struggle with fractions, so I want to go through one more problem with you before we move on to decimals. Okay, so the problem we're going to do is right here, n-3 divided by 2 plus n plus 5 divided by 7 is equal to 5/14. I'm just going to go through this one the first way, where we get rid of the fractions in the beginning. I think for me that's a preferred way, but I am completely fine with you doing whatever way you want to. So for this problem, we need a least common denominator for all 3 fractions. That least common denominator will come from 2, 7, and 14. The smallest number we can change each denominator to is 14. So the first fraction will get multiplied by 7/7 so that we get a denominator of 14. Now you can distribute right now or you can hold off, it's up to you. The second fraction will get multiplied by 2/2 to give us a denominator of 14. And the last fraction already has the denominator that we need, so there's no modification necessary. Okay, now we'll use our trick. We can choose to do whatever we want to both sides of an equation, and we are going to choose to multiply both sides by 14 so that all those denominators disappear. When we multiply and divide something by the same number, it simplifies to 1. This 14 is distributed. That's why each denominator cancels. This one also cancels, leaving us with just these numerators. 7 times the quantity n-3 plus 2 times the quantity n plus 5 is equal to 5. And then we can solve this problem as usual from here. So step 1 is distribute. We get 7n minus 21, distribute the 2, plus 2n, plus 10. Then combine like terms on each side. 2 variable terms combine to be 9n. Our number terms, negative 21 plus 10. You owe $21 and you have 10. You can pay 10 of it off and you still owe $11 equals 5. And get the variable on one side, numbers on the other. So we'll add 11 to both sides. bring this up here. And finally, undo the final operation on the variable. In this case, 9 is being multiplied by n, so we divide both sides by 9, giving us 16 over 9. Doesn't simplify. It's as good as it gets. So the value that would make this a true equation, a true statement, if we plugged it in and simplified, 16 over 9. So it would definitely be more complex to check, but it's possible. Okay. All right, let's move on to a decimal problem. Okay, decimal problem. A decimal problem is extremely similar to a whole number problem, so treat it exactly the same. There are a few techniques you can use that are a little different, only if you really want to. In my opinion, they're not as helpful as the fractions, so if you have another way of doing it, that's fine. Okay, so step 1, distribute. We're going to distribute this 2 to both items inside the parentheses, giving us 8 minus 2x. On the other side, we're distributing 1.3. So 1.3 times 2, you can use your calculator, gives you 2.6 minus 1.3x. Second step, combine like terms on each side of the equation. On the left, we have a number term and a variable term. They don't combine. On the right, number term, variable term, don't combine. Now we're in the third step. Get the variable on one side, numbers on the other. You can choose, honestly, at this point, there's 4 different good options. So if you start a different way than I do, completely fine. I'm inclined to like to have the variable on the left, but it doesn't matter. So if I want the variable on the left, that means I'm going to get rid of it on the right. I can undo this subtraction with addition. So I'm adding it to both sides of the equation. Now, I could choose to write this term wherever I want on the left side, underneath any of the terms. I'm choosing to write it under the x term because they combine together. So on the right, that is 0. On the left, we still have 8. Then we have 2, negative 2, plus 1.3 is minus 0.7x equals 2.6. Okay, now we have one variable term. We need to isolate it. Get the number terms on the other side, which means get rid of this 8. Subtract 8 from both sides. Leaves us with negative 0.7x is equal to 2.6 minus 8, negative 5.4. Okay, then our fourth step is to undo the last operation on the variable. So we have multiplication. We undo that with division. Include the negative, include the decimal, the entire thing. We want to get rid of everything except that x. Divide both sides by negative 0.7, which leaves us with, don't forget if you type this in, include the negatives, negative 0.7. We get a crazy number. You can round to 2 decimal places as a default. Your homework system will be specific on how far you should round. And I suppose since we rounded, we should write it as is approximately. I won't take off points if you write equals as opposed to approximately, but since this is an estimation, this is a little bit more appropriate. This looks good. If you typed this in, this division right here, and came up with some sort of error, it could be because you typed in minus instead of negative. On your calculator, there is a difference between those 2 buttons, so make sure you're typing in negative, which is at the very bottom on the row with 0. Okay, so there's a decimal problem. All right, let's do some practice then. Okay, so these 4 problems, 1, 2, 3, and 4, I want you to try them on your own. This is an important piece of the class, is that you get the opportunity to practice and then see the problem worked out so you can find where your mistake was and maybe see where you're struggling and know what you need the practice with. So these are the 4 problems I want you to go through. Pause the video, take as much time as you need to work through these problems, And then when you're done, hit play again, and we'll start to go through all 4 of them. A little quicker than the example problems, but I'll go through them and get you all the answers. So go ahead and pause the video. Okay, hopefully you've completed all 4. You should complete all 4. It's for practice. And now let's go through them together. So our first problem, whole number problem. First step, distribute. We get 6x plus 24. Distribute this negative 4. Remember, distribute the negative, including it. So minus 4x, and negative 4 times negative 3 is plus 12 is equal to 18. Combine like terms. 6x minus 4x is 2x. Our numbers, 24 plus 12 is positive 36. And get the variable on one side, number on the other. We have one variable term, so we'll subtract this number. (18 minus 36). Check for myself. Negative 18. And finally, divide both sides by 2, giving you negative 9. Okay, if you didn't get that, hopefully you can see where along the way you had a mistake and you know for future what to practice with. Okay, second problem, next page. Next, fraction problem. I'm going to go through this the way I did the second problem as well. So I'm going to find a least common denominator for everything and then get rid of the fraction. Our denominators are 3, 2, and 1. You need to look at every single piece as a fraction before you go through this problem. Now, it won't change what you find your least common denominator to be, but it will change when you multiply. So our least common denominator is 6. We want each piece to have that denominator. The first fraction gets multiplied by 2 over 2, 2x over 6. The second fraction gets multiplied by, we have a denominator of 1, we want 6, by 6 over 6. Giving us 30 over 6. And the last fraction gets multiplied by 3 over 3, giving us 3x over 6. This is usually the longest part of the problem. Once you're through this, the rest, not so bad. Then multiply both sides by that denominator of 6. And remember, this distributes. So each and every denominator, division, multiplication of the same number, cancel each other out, and we're left with 2x plus 30 equals 3x. Step 3. At this point, you can go back to those initial steps. We don't have to distribute. We can't combine like terms. So step 3, get the variable on one side, numbers on the other. We have 2 variable terms and only 1 number, so this one's already where it should be. We can subtract 2x from each side, leaving us with 30 equals 3 minus 2 is 1x. You never need to write that coefficient of 1. So we have 30 equals x. That last step of multiply or divide, not necessary. We don't have anything happening to x. So our final answer, x equals 30. Okay, our next fraction problem, same process. We need the same denominator in order to get rid of all fractions. So we'll look at this again as having a denominator of 1. Our least common denominator will be 6. We'll change each fraction. The first one gets multiplied by 2 over 2. 2 times a minus 2 over 6. The second one gets multiplied by 3 over 3. So we have 3 times a plus 3 over 6. And the last fraction gets multiplied again by 6 over 6. We currently have a denominator of 1. We need a denominator of 6. Multiply that in. Whatever you do to the bottom, do to the top. 30 equal over 6. Again, multiply both sides by 6. So that all denominators cancel out. And you could multiply this and then really do some crazy simplifying, but it's not necessary at this point. they'll all cancel, and you're left with just numerators. 2 times a minus 2 plus 3 times a plus 3 equals 30. For this line, if you distributed the 2 in the previous line, that's completely fine, and the 3. You can do it in the step from here to here. I'm going a little slower so you can see the progression. Then we'll distribute 2a minus 4 plus 3a plus 9 equals 30. Each of these distributed. Combine like terms. 2a plus 3a, 5a. Negative 4 plus 9 plus 5 equals 30. Then get the variable on one side, numbers on the other. Subtract 5 from each side. And finally, divide both sides by 5 to undo the multiplication. Okay. How are you doing? 3 for 3? Hopefully. If not, see where there was a mistake along the way. Go back and practice that problem again. Get the practice in the homework. But this type of equation solving definitely does not go away in this course, in the next course. It's here to stay. So this, this problem solving needs to be there. Okay, one more problem, our decimal problem. Decimal problem. For step distribute, we can distribute 6.5. So we get 6.5x minus 6.5 times 4.2 is 27.3. On the other side, also distribute. 1.5 times 3, x is 4.5x, minus 1.5 times 2 is 3. You can check on your calculator. Combine like terms on each side. Nothing to combine on the left, nothing to combine on the right. So we'll start adding and subtracting things to both sides. Variable term on one side, numbers on the other. I'm going to choose to subtract 4.5x. You could choose to do any of the 4 movements at this step. You could have subtracted 6.5, could have added 27.3, could have added 3. You just have to pick one. Once you do, the rest will fall into place. So 6.5 minus 4.5 is 2.0x. If it's 0.0, not necessary to write 0.0. I'm going to keep it for now, but if you didn't write it, it's fine. Then we have one variable term, get the number on the other side, plus 27.3. 2x equals negative 3 plus, we get 24.3. And then our last and final step, divide both sides by 2. We currently have multiplication, undo it with division. Divided by 2, we get 12.15. Okay, this decimal ended at a nice place. The previous one went on for quite a while. If it does that, you can always default to 2. If the number came up and it said 3 decimal places, I would write those 3 decimal places. Only round if the directions are specific on where to round, on something like a test or in the homework system. If the problem, like I said, if the solution goes to 3 decimal places and you don't have any directions on where to round, you should write the exact solution, which would include all the decimal places. Okay. All right, so here's our solution, 12.5. Again, you could take that, plug it back into the beginning, and verify for yourself that it's the right answer. It's up to you. You can always use your calculator there, so that's not a problem. But this is the end of our practice problem. So if you struggled with any of this material, feel free to go back and watch the video as many times as you want to. Use your textbook as a resource. Use the tutoring center as a resource. Use the homework as another place for practice. But good luck with the homework. Make sure you get into that system as soon as possible. And then I will see you for another video soon.